Hi college algebra students, welcome to day 5 of our preliminary review, and today we're going to talk about some linear inequalities to get us started. So for example 1, we're going to solve the linear inequality and we're going to write our answers in interval notation. So whenever we solve our inequalities, we want to have the variable on the left side, and then we'll graph it as well as put it in interval notation. So first step would be to distribute our -4, so -4x plus 20 greater than or equal to 2x, 2x plus 15. Please move your x's to the left, so subtract your 2x, getting you a -6x greater than or equal to, subtract the 20, -5. When you divide by -6, notice you're dividing a negative. That should remind you to flip your sign. So it becomes x is less than or equal to 5/6. On a number line, I only require you to graph 5/6. It is a closed circle because it's less than or equal to, and you shade to the left. I write that though to help you see that when I do interval notation, the furthest left value is -infinity, and I go up to 5/6 with a bracket. And the graph is not required, but it's helpful when you put an interval notation. For part B, we now have a double inequality here because you have two inequality symbols. This just means you want to get x by itself in the middle. So we're going to undo it to all three sides in order to solve for x in the middle. So that means we're going to subtract 4 from all three sides, getting -12 less than 2/3 x less than or equal to 6. Undoing a multiplication of 2/3 would be dividing by 2/3. Okay? When you divide by a fraction, though, you can also multiply by the reciprocal. So I'm going to decide to multiply by that reciprocal here and multiply all three sides by 3/2. So I'll say it again. Dividing by a fraction is the same thing as multiplying by the reciprocal. When you do so, -12 times 3/2 is -18. The middle would just be x. 6 times 3/2 is going to be 9. From here, I'm going to do my number line to help myself out. You have -18 and 9. Open circle at -18, closed at 9, and that's everything in the middle. So when I write interval notation, I'll have -18 to 9, parenthesis, and bracket. So that's a little intro to your linear inequalities. Make sure you remember to flip your sign if you multiply or divide by a negative. Next, we're going to go to distance and slope. So a quick recall for you, the distance formula, d equals square root. You take your x2, subtract x1, square it, then add your y2 minus y1 being squared. So make sure you have that formula memorized as we move on in our units. Slope formula. Slope is y2 minus y1 over x2 minus x1. So for example 2, we're going to find A, the distance, and B, the slope. What might be helpful is physically writing out that this is my x1, y1. This is my x2, y2. Have it be with the points, and then we're really just plugging right into the formula. So let's do A first. A is the distance. So the distance equals square root. x2 is 6. I'm subtracting x1, which is 4, and I'm going to square it. y2 is 10, and I'm going to subtract -3. So notice when I subtract a negative, you get an addition. Simplifying here, 6 minus 4 is 2. 10 plus 3 is 13. Again, you want to show this work. 4 plus 169, overall square root of 173. If you can simplify that radical, we do expect you to do that. In this case, 173 cannot be simplified under your square root. Part B is now the slope. So looking at our slope formula, we'll take y2, which is 10, subtract -3, which gets you to add 3, and then x2, which is 6, minus 4. Simplifying, you get 13 over 2, and you can't simplify anymore. So you're good with saying the slope is rise 13 over 2. Good tactic is writing out what is x1, y1, and just simply plugging in. Next on our notes is talking about forms of lines. So we have 3 types: slope-intercept, standard, and point slope. And then you want to know that for vertical lines, we really just care about the x value. And what I mean by that is a vertical line just has the same x value. So whenever you have a vertical line, your equation is just x equals whatever that x value is. A horizontal line will just be the y value because they have the y value in common. So let's try a couple. Write an equation of a line that is parallel to the x-axis and passes through -2, 10. A good tactic would be to draw a picture if you need. When it says parallel, it means you will not cross. You are parallel to its same slope. And it has to pass through -2, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, just a sketch. So it has to pass through this point and be parallel with the x-axis. So that means my line would look just like this. So I'm trying to write that equation. Going back to what we talked about here with number 4 and 5, this is a horizontal line. The horizontal line, I only write what the y value is because that's what it has in common. So in this problem, the y value is 10. So the equation is just y equals 10. For part B, write the equation of a line that is perpendicular to 2x minus 6y equals -18 and passes through the point 4, -7. Now, when we think perpendicular, hopefully you remember that means opposite reciprocal, and we usually use an upside down T to note perpendicular. First thing, let's find the slope of this line and then see what's perpendicular. So when we find the slope, we want to actually take it from standard form and convert it into slope-intercept. So I'm going to move over the 2x. I'm going to divide everything by -6. When you divide -2 divided by -6, you get 1/3 and plus 3. The reason why I did that is because the slope of this line is 1/3. Now that's helpful because I want to find the perpendicular slope. Well, if the normal slope's 1/3, the perpendicular slope is opposite reciprocal. So instead of 1/3, it becomes a 3, and you add that negative sign. So that's our slope we're going to use, and this point. We're going to plug into the easiest form. If you have a point and a slope, plug into point slope. So y minus -7 is a plus 7 with your slope, parenthesis, x minus 4. Again, plug it into the easiest form. You do not need to convert. Last example, write the equation of the line that passes through these 2 points. Well, in all of our equations, we need a slope. So that should be the first thing you do. Find your slope. Again, following the formula from the front page. It would be 11 minus -1 over 7 minus 2. So 12 over 5. Now we have the slope and either point. It doesn't matter which one you plug into. I'll plug into both to show that both answers will work. So y minus y1 equals my slope, x minus x1. Or y minus -1 equals your slope, x minus 2. Both are correct answers. Both will get full credit. Once you find the slope, you can pick either point. thing we're going to talk about is quadratic functions. So when we're at a quadratic function, this is what's called our standard form. This is our just quadratic function. Here is our standard form, aka vertex form, because you can clearly see what the vertex is. Again, all of these shapes are our U shape. That's a quadratic. So finding the vertex would be finding this point right here. One good tactic to use is the formula to find vertex of negative b over 2a. Or you could complete the square to get it into vertex form to find the vertex. So let's talk about our negative b over 2a, as most students prefer that method. So starting off, here's your a value, your b value, and your c value right in order of your quadratic. If you're plugging into negative b over 2a, well, negative b, notice the parentheses, over 2 times 1, I'm getting the x value to be 1. So if I were to graph this, it would be x value of 1 of the vertex, this point right here. Finding the y value, you want to take that and input it into your function. It now becomes f of 1. So practicing our function notation from our previous days, it would be 1 squared minus 2 times 1 minus 5. 1 minus 2 minus 5, which gives you negative 6. So this is telling me my vertex is 1, negative 6. So with example 4, we wanted to find the vertex, check, then determine if it's a max and state its value. To determine if it's a max, we have to see what way does it face. Well, looking at our a value, in particular, we always look at the a value. Since the a value is greater than 1, the a value is 1, which is greater than 0, we know the graph opens up. So if I were to graph, it would look like this, and it changes direction at the point 1, negative 6. So because it opens up, that means it's going to have a minimum. This is the smallest value, minimum. And the minimum value is the x. We always say the minimum is the y value. Oh, I'm losing it today. So the minimum would be the y. That is the smallest y value of your graph. So there's the vertex, and it is a minimum at negative 6. Let's try one more, and then you'll be free to go. So we're going to, again, find the vertex. So we're going to use our formula, x equals negative b over 2a. That came right from our box up here, our little conversion. So it would be negative 60 over 2 times negative 6, which gives me a 5. That's the x value of our vertex. To find the y value, we want to plug that in as our input into our function. Again, you have a graphing calc, so these numbers are going to get a little big, but that's okay. If you plug in 5, you should get out 161 as the y value. So your vertex, the place where it changes shape, is 5, 161. Looking at the a value, that's going to tell us if it opens up or down. Since this is negative, that means my graph will open down. It's going to open down and change shape at your vertex. So since it opens down, that means you're going to have a maximum. Again, the max or min only occurs at the y value. So maximum at 161. And that's where we will end for day 5. If you have any questions, feel free to bring them to class. See you soon.